Good day, everyone, and welcome to today's Digital Anarchist webinar. We're very excited to have you with us. Our topic today is a really interesting one. It's deconstructing cloud native in the enterprise, and we have two amazing speakers lined up for you. Today's webinar is sponsored by Liatrio. My name is Mitch Ashley, and I'll serve as your host and moderator for today's webinar. A few housekeeping items. We are recording the webinar, and following the end of the webinar, we'll send you an email with links to download the recording and also the slides. You can also get those on digitalanarchist.com. Our speakers, which you will find, they love questions, so we really encourage you to enter your questions into the questions tab of GoToWebinar. So please, we highly recommend that you throw out some questions for us. So let's move on to our topic, deconstructing cloud native in the enterprise. It's my great pleasure to introduce to you today's speakers. First up, we have John Willis, consultant and advisor to Liatrio. Now, John is a well-known industry speaker, co-author of DevOps Handbook and Beyond the Phoenix Project. If you've been around DevOps, you've probably heard John speak before, and he's a great speaker. We also have today with us Casey Lee, and very distinguished in his own right. He's Director of Engineering at Liatrio. He's also has the honor of being distinguished as an AWS Container Hero. Now, there are only a few folks around that have that distinction, so we're lucky to have him with us today. So let's get started. Casey, I'll hand it over to you.
Awesome, thank you, Mitch. My name's Casey Lee. We'll be going through this topic today of deconstructing cloud native in the enterprise. I am a director of engineering for Liatrio. Liatrio is a DevOps consulting company. We get the privilege of working with many large enterprises on their transformation journey, helping them increase the speed and safety at which they deliver software. So we'll get to use some of that learning and experience that we've seen through the years to share with y'all on what we've seen with cloud native, what works and what doesn't work. So I thought a good place to start, John, would be maybe to talk about and reflect back on a talk that you gave, I believe it was 2015, on faster, cheaper, safer. I think that'll really help set up the conversation today. Can you remind us a little bit about that talk?
Yeah, thanks, Casey. Yeah, John Willis here, also known as Machgroup. If you think about the end of this month, DevOps is sort of an icon, a term, is going to be 10 years old, right? Because the first DevOps day was in Ghent back in 2009, October, basically I think October 28th-ish. So basically, 10 years will be the end of this month. And one of the strongest things, even though as we started out, like sort of looking at this DevOps sort of movement, Andrew, Adam Jacob, founder of Chef, just said it's a professional and cultural movement, full stop, right? Like that was his original definition, and I still think that's a great definition. One of the sort of main themes that's sort of evolving is this idea of being able to go faster than you could ever go before, but being able to put in sort of the guardrails to be safe. And so this kind of faster, I mean, the original DevOps sort of character was a wall. Andrew Schaefer, who originally had a presentation where he had this wall of confusion where dev throws stuff over the wall. Dev throws stuff over the wall, and ops catches it, and they say, "What do you want us to do?" And there's this whole sort of miscommunication or wall, and then DevOps was about smashing that wall, right? So it was all about sort of developers want to go faster, ops wanted to go slower, and DevOps was like, "No, we can actually do both," right? And then right around those times, like late 2007, 6, 7, 8, the cloud, Amazon Web Services became sort of dominant new patterns of doing all sorts of things. Code and infrastructure started happening. Usually it wound up sort of being defined as cloud native. Long story short, it was clear. I think Adrian Krakoff, the original architect of Netflix, was the first one really I ever saw talk about faster, cheaper, safer. And then I drove a whole meme on that with a whole bunch of presentations, 2015, 16. But again, the idea was that there were certain practices, technical and social, so cultural behavior patterns that you could put in place where you could be faster and safer, more resilient, and then throw in sort of cloud and open source, and you were cheaper. And what the real thing that became very important in 2015, the reason I got really excited about this is that was the first sort of real report that came out from IT Revolution, Gene Kim, Nicole Forsgren, and Jez Humble, that where the research, the actual industry peer-reviewed research over time told us, the data showed it was that you literally, and the numbers varied over the years, but consistently every year when they run the sort of DevOps experience reports today called DORA, that if you had certain patterns, go too deep, but it's Ron Westrom, based on Ron Westrom kind of model. Ron Westrom was a sociologist. If you had certain patterns that were generative versus pathological, and that you could be anywhere from 100 to multiples of 100 times faster, but the key was that you would be more resilient, 100, some cases even 100 times more resilient. And that was the thing that really sort of kicked off this idea that we not only we knew this from sort of watching this movement, cloud interjecting and all this, but then all of a sudden we're seeing sort of research data. I mean, real the psychometric, based now over the years peer-reviewed data that said, this is true. And and so I think so we live in a world now where you actually can, depending on sort of your sort of cultural and behavior aspects that you want to apply in your organization, and then the sort of technical patterns that you apply. And then so I'll say one last thing. I've been a fan of Liatrio for quite a few years, going back with my sort of podcast with Damon Edwards and our DevOps Cafe podcast. And so I've been sort of tracking what you guys have been doing, and I think you just sort of followed, you have been following this pattern of really hitting the sort of behavior cultural with the technology. It's not just throwing in pipelines. I mean, you don't just gawk in and throw in Jenkins and pipelines and use containers. That is half. It's less than half the story. You have to sort of build a social technical strategy anyway. And I think the good news is the reason Casey wanted me to point this out in the beginning is because what we're going to talk about here is a great example of this discussion of how what we call deconstructing cloud native.
Yeah, thanks for bringing that back to top of mind. I think that the reason that message, that faster, cheaper, safer, it was so important when we first started talking about that 5+ years ago, but it's matured. We've got more newer techniques that have evolved where it's actually becoming realizable, not just in the Netflixes, but also in the enterprise. And so good segue into what I wanted to get into today, which is how do we allow the enterprise to go faster, cheaper, safer, right? So John, tell me, what is your take on cloud native, and tying back into that idea of faster, cheaper, safer? What do you think on cloud native?
Yeah, I think originally, I mean, so I was also originally about sort of one, there was probably a handful of what we called kind of cloud evangelists back when Amazon was just, kicking off sort of EC2. I mean, literally there was, I can name the people, and I fortunately fell into being sort of one of those. And one of the things we saw over the first 3 or 4 years is sort of people trying to take enterprise, legacy apps and try to forklift them without changing any of the sort of patterns of how they were built onto cloud. And the first 3 or 4 years of sort of enterprises, entree into Amazon cloud services was disastrous, because there was, the idea of using commodity hardware, and that's basically what Amazon offered early on. And so there started becoming this evolution of, you had to rethink how you were going to move enterprise, really any type of application, but for the enterprise, they had to start rethinking how they were going to sort of, this first phase of just forklifting applications as is that ran on, $1 million hardware, IBM RISC or Sun machines, and putting them on sort of commodity where so just a single, syscheck would like blow the whole application up. So that started this journey. What happened though was the enterprise had already sort of been down this journey for quite a few years, but I always felt that the tech, when I thought about it, in retrospect, the technology was never aligned. So you had SOA back in the day, you had Eric Evans domain driven. I mean, those things were starting to throw promise, but now all of a sudden you got the cloud, and you start thinking about sort of how do I sort of deconstruct applications. And so today I think we call that whole primordial soup cloud native.
Right on. I've got a couple stories I wanted to share, actually. You made me think of there when you talked about some of those forklift upgrades, John. First story that came to mind was working for supporting consulting with a healthcare startup, and they had this .NET application, and they wanted to lift and shift it to AWS. And there was some automation there. We did some cloud formation for the infrastructure for the EC2 instances, but installing the app was a manual install. It was like, okay, give the developers the VMs and let them go to town on it. The problem was they were unable to implement any sort of auto scaling because, well, obviously if there's a manual install step, you can't scale out and scale in. The other problem was the app was designed very stateful. All of the state information, the session information was in memory. So it was definitely not cheaper. It was much more expensive. They got their first bill and they freaked out a little bit. Solution was ultimately, I think, and this is where you were going there, was the app had to get re-architected a little bit. We had to move the session database over to SQL Server, started creating AMIs for the application so that it could be launched with automation. And then we were able to configure auto scaling policies so that we were able to scale the instances out and in response to load. Another story that comes to mind was there was this other company I was consulting with, a hospitality company. They were doing these Java microservices, did a pretty good job actually in decomposing their app. Full automation, auto scaling was in effect, so they were realizing the cost benefits. But the problem was these microservice calls were all chained together, and they had an outage, and it was caused. If I were to ask you, John, what's like the worst kind of failure you can think of from a system?
Well, let's see, cascading failure that doesn't use circuit breaker patterns.
Yeah, exactly. And it was caused by, I mean, it's one thing if a service gives you back a 500 server error, right? Because then you could kind of handle it. But the worst kind of failure is when there's no response. And so the system, this one service kind of backed up and stopped responding, and that triggered the upstream services to start backing up, and it cascaded throughout the entire system. I think, what is it, like the default Java timeout is 60 seconds or some crazy number like that. They didn't have defaults, or they didn't override the defaults, and they're hitting about 100 requests a second. So some quick math, Little's law, I think was 60 times, about 6,000 requests are now in system when the default thread pool is only like 200. So needless to say, all these JVMs start falling over all over the place. So again, went to the cloud, good architecture, but missed an important step. The solution was to apply, like you were getting at there, circuit breakers, sane timeouts, using bulkheads for the client so that one downstream service wouldn't trigger another outage. One last story came to mind, and that was working for a financial service company, and they were decomposing their monolith for this consumer credit card app to microservices. They brought in PCF, Pivotal Cloud Foundry. They had all this automation. They had the auto scaling. They had a very slick deploy their apps to the platform. The problem there was, they had implemented circuit breakers with Hystrix, but they never built out continuous delivery pipelines. They had some levels of automation, but there was no automation for the entire end-to-end process. And so they were rolling up all of their microservices into these release trains, quarterly releases. And so even though they did all this work to build all this new services and containers and all this cool stuff, they were still on a 3-month release cycle. And so the solution there was, okay, well, build pipelines, decouple the deployments from each other. And so I share all those stories for this. What do they all have in common? They're all missing one of those faster, cheaper, safers, right? But the real thing they all have in common is this: they were all running on the cloud, but none of them were cloud native. None of them were able to actually deliver faster, cheaper, safer. So I think the important thing when we're talking about cloud native is to understand that the very first way to define cloud native is that it's not about where the app is deployed, but it's how the app is architected to take advantage of this cloud computing model.
And it's interesting too, Casey, as you point that out, right? Like you had this sort of DevOps, right? And it's had a good run, right? And 10 years, and and then somewhere along the way, somebody codifies a lot of sort of principles, from SOA to domain driven to 12-factor to, all around sort of cloud and cloud native. And I think cloud native is an important. But one of the things I think sometimes people get lost in is, sort of the territorial nature of like, this is cloud native, this is DevOps. But I think one of the things that's happened very well is more people, more than the less, I guess, have seen the two as very, coexistent, right? In other words, like you can't really do cloud native without, if to say there is something called DevOps. But the patterns, and I think you pointed out very well in that last example of that like building like microservices and all these things are all for naught if you can't deploy, if you only deploy once every 6 months, right? I mean, like, you don't have the hygiene around sort of what is the DevOps piece in that you're sort of getting all that. And so cloud native really sort of encapsulates DevOps, which DevOps sort of doesn't really work real well without cloud native, and that all sort of implies that it's more than just code. There's a lot to the system, including not just code, but the way you do infrastructure, right? The way you use infrastructure as code, you do continuous delivery, and then as I alluded earlier, it also has to be bedrocked on sort of a cultural behavior patterns. Yeah, no, good point.
And I would describe cloud native in terms of these three characteristics, and it's really just some different words for faster, cheaper, safer. Agility, which is, hey, how fast can you move from idea to production? It is a common question I ask customers or folks in the industry, and the number one answer, what impedes you to delivering, is aversion to risk. So that gets to that safety part, which I call that as resiliency. How do we make sure our system is resilient? How do we recover quickly from an outage? How do we avoid cascading failures? And then elasticity, which is kind of that original cell of the cloud computing model. It's like, how do I make sure that I'm using the exact amount of resources that I need based on my current load? So these are the kind of the three characteristics that I like to use to help describe what cloud native is, which where you're going there, John, it's all about outcomes. Like if you do all this cool stuff and you all this cool tech, but you haven't achieved agility and elasticity and resiliency, then it's kind of a waste.
Yeah, I mean, at the end of the day, going back to fast, better, cheaper, what we learned from the sort of DORA reports, and right, it was about, sort of some sort of bounded metrics about like tracking your lead time and then tracking sort of your resilience and making sure those correlate together, right? Like, are you getting faster? Because I mean, the trick is today, right? Like, I don't care what business you're in, your ability to go from whiteboard to sort of, we used to call the aha to ka-ching, the register ka-ching sound, cash register. Like, I mean, that today sort of defines you, like how, no matter what business you're in, can you sort of turn on a dime? Can you use information? Can you take intel? Do you merge? Do you acquire? How quick can you basically, sort of get something from, some really smart engineers and sort of delivery people to actually be in the face of a customer, but be the assurance that like that you can do that fast and and like turn it off, or we'll talk about some deployment strategies, and so that you can do it safely, so that you don't sort of balance the risk. And then I think there's a little bit more to elasticity. It's not just sort of auto scaling, and it's this whole what's happened since 2007, 8, 9. I would say this stuff really started in earnest in 2010, in my opinion, particularly in the enterprise. 2011, maybe, where the enterprise started showing up at DevOps conferences, and which is open source, like the ability, it's that whole cost thing to be able to use we all know if you use cloud inefficiently, actually be more expensive than racking and stacking yourself. But if you're pretty clever about how you use cloud resources, and then you're clever about how you choose the technology software that you have to use, I mean, they be, like crazy, cost savings, and actually that can be turned into more people hires, right? Which then, so again, I think this is a nice way to sort of, kind of rebrand the faster, better, cheaper, or safer.
And so those are the outcomes. How do we actually get those outcomes? So there's these 5 cloud native techniques that we'll talk about through our conversation today. So containers, how do we repackage our applications so that we can quickly, reliably, consistently deploy them? And my opinion here is that containers really is all about providing parity between the local development environment, the local workstation, and wherever it is that you're ultimately going to run the app. Continuous delivery, which is an approach where software is produced in short cycles. I like to say that every commit has a chance to get to production. Is if you're implementing continuous delivery right. And what's crazy is folks often hear that and they're like, oh my gosh, that sounds crazy. I thought we were decreasing risk, and that moving to production that quickly is making me nervous. It's like, well, let me ask this, what's more risky? A developer deploying an hour's worth of work or a month's worth of work, right? Microservices. So this is an approach where application is decoupled into loosely coupled services. Automation, where every step along the build, test, deployment process is automated. And then there's automation for the automation. Like, you can't just have local optimization where you automate just infrastructure, or automate just configuration management. The entire process from commit to prod should be automated. You want automation of your scaling. You want automation of your recovery when there's failures. And then last is observability. And this was like an oh yeah, I guess we should add this, because once you take your app and break it up into microservices and you start having this ephemeral infrastructure that's coming and going, you realize very quickly that the ways that you used to measure and monitor your application don't really hold up in this new model.
Yeah, and if you sort of summarize this whole thing, which I'm about to do, which is, all this is about sort of removing human sort of intervention that could either slow you down or cause sort of risky, anytime you sort of manually do anything, and then basically creating shorter feedback loops. So even containers, right? Like the one of the promises of sort of containers and actually deliveries on the promise has been that you move a lot of sort of human cruft in just VMs. Whether you have automated VM allocations or not, containers gave developers a way longer roadmap, roadway or road entree, whatever, onto to be able to get their sort of containers production without sort of friction between, like, I need a VM and it's got to be, built this way. Continuous delivery obviously is the ultimate sort of feedback machine, right? Getting sort of break the build, or so kind of red, green, and then sort of microservices again allowed sort of developers to sort of componentize automation. Obviously, anything that can be automated should be automated, so that there aren't manual checklist steps, things like infrastructure as code, or Kubernetes and containers. And then sort of observability is that dealing with the runtime, of how you sort of, again, it's all about sort of feedback and reducing manual sort of potential for manual sort of intervention or manual sort of handoffs.
So,
yeah,
John, what do you think? How does cloud native benefit the enterprise? Why should the enterprise care about this?
Yeah, no, I mean, they clearly have to, right? Like, so, part A is they have to, because of all the things we've mentioned, like ability to get faster to be faster, be more resilient, and get faster feedback, right? Like, all those things, and then sort of reducing the toil around, human factors where they can be. I mean, the thing I've always been a strong believer is that like you don't automate everything. There are things that basically actually make sense for humans to do, but you automate wherever possible where it does make sense. So the enterprises, this is how they get the advantage. You and I have both seen large financial institutions that are just pulling away from their competition. I mean, the things that they're doing, and you go visit these, you go visit some financial institutions and you scratch your head where they're still taking 2 weeks to get a VM allocated, and you walk to another place where they've got like a whole floor in their building as a dojo, and it's not a fake dojo. It's really, they're sort of transforming teams at scale. New teams are coming, legacy teams are coming in and being immersed in this new way of doing stuff, and all built around this cloud native. Now, the key, and I think one of the interesting things we'll get into is how do you do it in the enterprise, right? Which is, just to sort of drop a foreshadowing, is like things like strangler patterns and stuff like that. So, because the enterprise has this unique variable, which is they have, 50, 60 years of 5 generations of technology stacks that are all active. Top 100 banks in the world still run IBM mainframes. As record, so there, what you have to do is sort of go in with these sort of special kind of gloves, Batman gloves or whatever, to be able to do. I mean, you need to do cloud native and all the things that we've gloriously talked about in the last 10 or 15 minutes, but you have to sort of surgically do it in the enterprise a little different because of their constraints. You just can't rip out 40-year-old system of record data that represent trillions worth of assets. Like you have to figure out how to work around that. And what does it mean to you, buddy?
Well, to me, cloud native is a way to answer this question. This is a slide I stole from Rob Brigham from AWS. It was from a reInvent talk back in, I think, 2015 that he did. And his point with this talk was that you've got developers on the left, and they've got all these fancy tools in green there to build, test, release, and deliver software to the customer. And then you're getting feedback from the customer every time you're doing deployment. His point was that the business partner that the developers are supporting, they don't care about your fancy tools. They don't care about your fancy pipelines. All they care about is how fast can I get stuff from the left to the right? And how frequently can I do this so that I can get more feedback? So ultimately, the goal of cloud native is increase the speed and safety of software delivery. Why it matters to me is that these enterprises are in a position where they are locked up, waiting for forward progress, waiting to be able to deliver the things that their customers want. And so ultimately, cloud native is a way to turn IT not into an impediment, but into a supporter of the business.
Yeah, no, and again, I think circling back in, this is a great way to sort of, it's about, one of the biggest things, like I said, is shortening the feedback loop, right? Like getting sort of feedback as early as possible. Shift left is sometimes referred to, or as you find things downstream, you sort of push those. Gene Kim, as part of the Phoenix Project, called the 3 ways of DevOps. First way, sort of left to right. Second way, right to left, which is about amplifying feedback groups. And then the third is sort of the whole, kind of soup of continuous improvement. But yeah, I think this picture is a really good one snapshot, tells it all. Yeah, so this is one, I've seen you sort of talk about this slide and all. Casey, I really like the way you sort of, people are always trying to describe microservices to the layman, right? Like it isn't that hard to describe, but I think there's a lot of nuances of when you, it's, the simple sort of explanation of like we're breaking monoliths into sort of bounded, code. I mean, it's simplistic, but the truth is, for somebody like you who actually works in a lot of large organizations, and have had a lot of experience of dealing with this, I thought you reviewing this slide, it was interesting when I heard you first present this.
Sure. So first, got to give some credit here. A lot of these ideas came from Sam Newman, wrote a great book, O'Reilly book, Building Microservices. Highly recommend it as a way to just kind of get a lay of the land.
Damn right.
So there's 4. I think he has like 7 principles of microservices. Yeah. I boiled it down to these 4. So the first being team autonomy. Microservices ought to enable teams to operate more autonomously, which means that if one team, for example, wants to pull in a new version of the Spring library, Spring framework, they could do that without having to get all the other teams involved and regression test their monolith. So it allows teams to operate independently, which allows them to move at whatever pace they want. If one team wants to do daily deployments and another team wants to do weekly deployments, that would be enabled. The second principle is this idea of independent deployments, which enables blast radius control. So in this picture, what we see is a situation where one microservice might be saturating resources, CPU resources maybe, and it needs to auto scale. So the saturation is contained just to the one service that is being impacted, and then it could scale independent of the others. So this is a way to isolate systems from each other. So these are two benefits that if you're not realizing these, then something's not right in how you adopted microservices. And then the other two principles that I like to discuss are that microservices ought to offer public APIs for their capabilities, and those APIs should be documented. Those APIs should be authenticated, and authorization should be included with every API, and they should have some sense of rate limiting associated with them, so that you can maintain certain service levels. But this then leads to the final principle, is that all the implementation details of the microservice ought to be kept private. So if you're exposing, let's say, a RESTful API and behind the scenes you're using a database, that database should only be consumed by the microservice that owns it. And why is that? You may have heard people say this before, but there's a really important why. And the why is back to the first thing, which is team autonomy. If you have folks accessing the private implementations, the databases directly, then you lose the ability to make deployments independent of each other, because it's really hard to do versioning of a database. It's much easier to do version control at like a RESTful API. So by keeping all of the contracts, all the coupling at the public APIs where you can implement versioning, you're able to operate independently, and you keep those things that are a little harder to do versioning, keep those things private.
Yeah, no, I mean, I was fortunate that Sam had sent me an early copy of that book, so I got to read it really early in the sort of life cycle. And I remember, one of the parts that I really liked is this idea of sort of the public API idea that, that you sort of treat like these sort of services as if they're going to be externally referenced no matter where they are, right? Which sort of opens up a whole different way of thinking about your architecture, right? I mean, I think when you're sort of thinking, not just a monolith, but old sort of legacy think is that everything's sort of behind the firewall, and you have this, you can kind of cheat on a lot of decisions, and when you start thinking about like every sort of service, it doesn't, from the way you sort of architect and design it, it can be called from anywhere. It affords you to sort of create more sort of resilience in so many ways. And then I go back to Adrian Krakoff's first presentation I saw him give on microservices, and he really sort of drove the team autonomy idea really strong, which is, one of the examples is like any language, you weren't bounded by sort of like, sort of this company uses this language as our predominant framework. Teams can actually figure out like what are the, there's some good presentations at DOS about Walmart and, what is it? Is it F#? I always forget the functional languages, right? And they've done incredible things with, the sort of I guess, I don't know if you'd call the Microsoft functional language deviance of .NET. I don't know. I'm out of my depth. Help me, get me out of this. No, but like you listen to, I got to interview one of the guys over there, and they present. It's like it's phenomenal what they've been able to do, sort of with autonomy, with that, what I would think for me personally is a very obscure language, Microsoft.NET functional language. So yeah, no, good slide.
So the next question becomes, well, what does cloud native actually look like? So we recognize that the enterprise wants to move fast, they want to be safe, and cloud native seems like something that is offering that to companies. So what does it actually look like in the enterprise? And so what I wanted to go through here, John, was kind of some of three of the different kinds of things that we tend to see in this progression and adoption at enterprises. And so the first one I was going to talk about here was this transformation that you see. This is going from, on the left, we've got an application that's running on VMs. There's an F5. There's a whole bunch of teams involved with passing tickets around to get various parts of the application deployed. And then on the right, you see kind of the to-be architecture, where they've adopted an orchestration system for containers. In this case, we're talking Kubernetes. We see that those VMs are now, and the applications running on them have now been encapsulated as containers running in Kubernetes. We've got some deployment resources that manage the pods for the applications, for the stateless applications. And then we've got some stateful application, the database running as a stateful set with some persistent volumes backed by EBS volumes. And so this kind of migration from traditional VM and people passing tickets, we see it that migrates into this Kubernetes type deployment with, then you get into this model where the provisioning is all done through pipelines. Jenkins is still strong as can be, and we're seeing that a lot of folks are looking to instead of having like one big monolithic Jenkins that manages the entire enterprise, Jenkins is per team, and hiding some of the complexity of that behind things like either GitOps or ChatOps types tool like a Slack integration.
Yeah, that's cool.
The tooling also starts to change a bit here, where instead of having Jenkins know all about all of the different components necessary to do the build and deployment, a lot of that logic is being pushed into containers as well. I mean, how many times has an organization struggled with a situation where somebody in the org requests a plugin to be upgraded or installed, and they do some testing and they're like, all right, here we go, let's upgrade the plugin, and then boom, like 10 people's pipelines stop working. It's a mess. It's very painful. Or a situation where the build works fine on my local machine, but once I get up to Jenkins, like the Maven version isn't right or the version of Node.js isn't right. These disconnects in the environments causes tons of pain and really increases the feedback time. So in this case, folks are embracing tools like Helm to package up the application, and then Scaffold, which allows you to have a very similar build run environment on your local laptop as what Jenkins is going to run. So a lot of the logic gets pulled out of those Jenkins pipelines and pushed into your Scaffold definitions.
I love the idea of the Scaffold as this nice abstraction. You know, we've talked about use for infrastructure as code, like why you would use sort of Chef or Puppet, you know, or Ansible or whatever today, Terraform, but to sort of create consistency, you know, between different sort of environments, your sort of local dev, your QA, your pre-prod, prod, right? But that solved only part of it, right? Which is I mean, again, you can Chef or Puppet, you know, Jenkins, but like putting like this complexity together, and it's sort of what I like about Scaffold is this idea that it's taking a whole nother part. If we go back to the original, like what is DevOps, what is cloud native, right? It's more than just code, it's more than just automation, right? It's sort of all the things, and so part of all the things is getting consistency in the complexity of your builds. So it's one thing I really like about Scaffold.
I can't tell you how many times I've embarrassed to admit this, but everyone's done this. You do these commits over and over again because you're testing your Jenkins file, right? And you look at the commits history and it's like testing Jenkins. And you just commit, push, and that's a painful process. No one likes doing that. And so this is an opportunity to pull that local and give you a chance to do that debugging locally.
That's cool.
Observability. John, you had some strong opinions on this.
This is another area, you know, we'll get into sort of one of the things I like that we'll sort of end with is an Ignite lab that Liatrio has, and what I like about it so much. But one of the things you do in there is you do this really good job of sort of explaining some observability. Sorry, must have had not enough coffee today. In like how it relates to metrics, logging, and tracing. Anyway, so I was just wanted you to kind of go through that because I really enjoyed the way you put it together.
Sure. Yeah, so the challenge, I hinted at this earlier, the challenge is you decompose your app into a bunch of microservices, and you're like, woohoo, everybody can go to production whenever they want. And then all of a sudden you have an outage and everybody's looking at each other like, where's the problem? I don't know. How do we track this down? And so observability is really this idea that we're no longer able to determine the state of the system by looking inside it. Rather, we have to look at the outputs of it. And Honeycomb, Charity Majors, really thought leaders in the space, that's how they define it. And they talk about there's kind of these three pillars, three different areas that you can focus on to improve the observability of your app. But what's really interesting about this is that not one of them completely covers all of the requirements of observability. And so let me go through these real quick. So the three pillars being metrics, logging, and tracing. And so metrics, this is, for example, using Prometheus to scrape metrics about various things in your application or your infrastructure, and then maybe visualizing it in Grafana. And metrics is great in that the cost is scalable. As you increase the amount of traffic, you can predict with reasonable estimates what the cost of maintaining those metrics are going to be. You're able to like roll them up over longer periods of time to summarize the data. Metrics are unsampled, meaning that 100% of transactions contribute to your metric. The struggle with metrics is this third one, cardinality. And what I mean here is, let's say you've got a e-commerce application and you wanted to measure response time by somebody's first name. You can't do that. Your Prometheus is literally going to fall over if you try to include labels on user first name. It just can't track data at that level of cardinality. So it really is only valuable when you're looking at things in more coarse-grained perspective. Logging is very expensive at scale. If anybody's managed like an Elk stack or a Splunk cluster, this would you know that the cost of storage and everything is painful. But logging is unsampled, meaning 100% of transactions can be captured in your logs, and it is immune to high cardinality. You can capture whatever data you want in the logs, and the tools that are available there make it easy to sift through and pull analysis data out of those logs. And then tracing is scalable at cost in that you can predict the cost. The challenge with tracing is that it's sampled data. So generally what you do is you say, I want 1% of transactions to be traced, meaning I'm going to collect all the details, the request payload, the response payload, the breakdown the time by every step of the request, by every function. I'm going to capture all that data for 1% of transactions. So it's very helpful in troubleshooting systems, but you don't have all of the data available. So you need to make sure you set your tracing numbers right. So point being, all three of these need attention. All three of these require some focus in order to get this observability thing right.
Good. No, it's awesome. Thank you.
So that brings us to this question of, okay, where does the enterprise start? How does the enterprise get going with this idea of cloud native? And so this was a challenge that we ran into with a lot of folks that we were talking to, either customers that we were working with or just other folks in the industry. They're like, yeah, I'm hearing all this stuff, and I know, I hear the results. I go to conference and I hear these companies having great results. I read the blogs, I do the research, but how do I get started? And this is really hard. Like, for example, if you want to get going with some of this stuff, like you want to stand up a Kubernetes cluster and start running your app as a microservice, you've got to stand up a Kubernetes cluster. You've got to stand up the control plane and the nodes. You've got to configure some form of auto scaling for the infrastructure so that you're scaling those VMs based on the utilization of the cluster. You got to set up integration with DNS so that you've got ability to resolve names for services inside the cluster. You're gonna have to integrate with some sort of a load balancer so that you can get traffic into your cluster. You're gonna have to come up with a solution for doing TLS certificates. You're gonna have to solve metrics and logging, come up with the RBAC rules, the role-based access control for the cluster, configure resource limits, cost management, and that's just to get a Kubernetes cluster up. Then you got to actually install all these tools and start playing with it. So what we heard from people was it's hard to even get started to evaluate this stuff, to figure out if it's something we even want to go down the path. And so something we did at Liatrio was we created this thing called the Ignite Lab, which is a one-day workshop for folks to get their hands dirty with all of these tools without having to run it in their own cluster. So we've been running these at various DevOps Days events, various conferences, and we invite folks to come in and they run through this exercise on our lab to get experience with all this stuff.
Yeah, no, this is probably the most exciting thing that I've been involved with you guys. I love being an advisor for Liatrio, but the first time I went to was the one in Dallas, and when you showed me the agenda, I was like, there ain't no way these guys are gonna get this done. This is a hands-on lab. This is like a lab that basically, like we'll tell you what they cover in a minute, but and not only sort of the meta of sort of containers, Kubernetes overview, microservices, deployment strategies, observability, like actually sort of lecture style, but also actually hands-on where you literally implement a monolith, and then you do a strangle pattern, and it's and I just thought there was no way that you guys were going to be able to. There was what 12, 13 people in the Dallas lab. And everybody finished the lab, and they were all variant skills too. It wasn't like everybody was a rock star, and they did. And I think it was the way you put it together. You drove it through Slack. It was just kind of the way you guys sort of work with your customers is sort of start driving stuff to sort of a collaborative tool like Slack with GitOps patterns, and then the stuff that Casey's been talking about, like scaffold, Helm, containers, Kubernetes and containers. An example of, go to the slide, sort of an old vFabric application, and then putting in sort of an adjunct sort of strangle pattern with a Spring Boot on top of it, all using sort of, Helm charts and delivery, and then sort of watching that flow to the strangle pattern, meta definition, then example, and then working your way to sort of even to like, I'm a big fan of what, I don't think people use distributed tracing as much, but Jaeger and Istio and Flagger for Strangle. I mean, like Kali, all these tools. It was just incredible. I mean, it was just I honestly was sort of blown away by this, what you can accomplish. And I'm not selling here, because if you're not buying, it's your loss. I mean, what you get out of this one-day lab is if all this stuff sounds intriguing to you, I am honestly telling you, as honest as I am, that this is a killer one-day event.
Cool, thanks, John. Yeah, it was fun having you there for the Dallas lab. And the part of what was the motivation here? The motivation was to demonstrate something real. You talked about how there's a monolith. Like, we didn't want to just do. I've seen a ton of these Hello World workshops on cloud native, and we didn't want to do that because the very first question you get, someone raise their hand and they're like, okay, this is great for this simple Node.js app. What happens with my Java monolith? And conversation over. So we started with, we found this this monolith that was open sourced by Pivotal back, I think like 8 years ago was the last time there was a commit on it. And we said, let's start there, like this big, ugly Java application. Let's get this thing running in Kubernetes. It has a proprietary database. We got to figure out how to run SQL Fire inside Kubernetes. So like it's a real representation of what an enterprise is actually going to run into when they try to adopt this type of stuff. And the other thing with the lab was we tried as much as possible to use off-the-shelf open source best practice tools. So there's no Liatrio is not a product company. We don't have a product that's in here that we're trying to sell. It's really just demonstrating how you would cobble together all of these different tools that are out there to get them all working together effectively to deliver an app. So we have a few of the tools that we wanted to highlight, a few of the parts of the experience. So this first was the Slack automation, John.
Yeah, no, again, it's it's really cool. And I think one of the reasons why you were able to do it in one day, in one sense, you're like, oh my God, I wish I could have a 3-day version of this, right? Which you guys may do in the future, but like that you drove everything from Slack, right? So you literally had people go out, sort of get their sort of Cloud9 sort of free instance, and then you sort of instrumented the Sparky thing, which was cool, and it was all literally like a lot of the sort of instrumentation, like installing Kubernetes and setting up a lot of the installations, everything was basically done sort of automatically to just kind of sort of like Slack commands via this kind of Sparky interface that you had added, and then that helped drive the reality of using this. Wasn't fake stuff. You were literally building a legacy Java application in Kubernetes in the cloud, and then you were sort of building Spring Boot. And I just the way you guys had put, and then again, that's how you sort of implement. That's how modern customers, the more you can drive everybody from sort of some sort of collaborative tool like Slack, the more efficient the collaboration gets, the more tighter the variation and the control of the things you're doing, your sort of history, your sort of audit of what happened, all go back to sort of this common place that everybody communicates in Slack. So it's the right way. It's not only that it was the right way for the Ignite Lab, it's the right way to actually run in the real world.
Yep. The idea being that when you need to do pipelines, you just go to Slack, you talk to Sparky, which is this bot, and you say, give me a Jenkins instance, creates a Jenkins instance, creates the namespaces, and then you can run your pipeline. So it makes, it like you said, it's really the only way to get through that much material with a group in a day.
Yeah, and then we talked about the strangler pattern, right? Again, that you were able to sort of show people how you can take an application, sort of strangle it out from the legacy. But this Kali thing I thought was really freaking cool, right? Like I hadn't seen this before.
Yeah, so we're using Istio as our strangler pattern. Strangler pattern being a pattern that first I heard about it was from Martin Fowler, where when you want to decompose a monolith, you put some sort of a proxy in front of the monolith, and then you're able to selectively route traffic away from the monolith to your new implementations, your microservices. So that's exactly what we do in the lab. Once we get this monolith running on Kubernetes, we then take one capability from the microservice, from the monolith. We create a new microservice. We use Istio to selectively route traffic for that one microservice to it. And then Kiali is a nice tool that visualizes everything going on in your service mesh. And so we could see, this is just a recording on loop of, so here we see all the traffic is hitting our monolith. This was the initial state, and then boom, microservice is deployed, and Istio is now routing that one capability market summary over to the microservice, and then we're watching it come online here.
And that was the Spring Boot app, so that was really cool. They had the sort of vFabric, and then you sort of strangle that into a Spring Boot app, this is real stuff, man. It's cool.
The other thing that's cool with this approach, we didn't touch the monolith, right? We deployed the monolith and then we left it, and you're able to do all this routing away, only touching the microservice. And your rollback, well, just undeploy the microservice, the Istio virtual service goes away, boom, traffic falls back to the monolith.
And it's good, custodians open source, all this is open source too, right, Casey? Right?
Yes, that's right. Yep.
That's really cool, right? So even though some of this stuff might be hidden for you in the one day thing, using Slack and all, but the truth is, it's all there. Like, so when you go home, you can literally deconstruct the whole thing. So
that's right.
Yeah, and then obviously in this example, it's canary deployment, but we talk a lot in sort of DevOps and cloud native, the idea of deployment strategies, right? Dark deploys, canary deploys, blue greens, all that. So here again, there's a whole nice meta section in the lab about sort of deployment strategies, and then a real live example of using sort of canary deploys. And this is the one where you use Flagger in the, or was that part of?
Yes.
Yeah, cool. Yeah, tell us about the Canary deploy example.
Sure. So we're using a tool here from Weaveworks called Flagger. And Flagger is a operator that's running in the background, and it's monitoring new deployments to the cluster. And what it's able to do is then selectively route percentages of traffic to the new deployment. And then over you configure the times and the percentages, but over time it increases the traffic going to that new Canary deployment, all the while monitoring Prometheus, whatever metrics you give it. And if there's any problems, Flagger will initiate a rollback. It'll rip the Canary back out. So this is a great way to increase safety by automating the monitoring and rollback of deployments, all while limiting blast radius by only selectively routing percentages. And so what you're seeing here is a visualization. We, in the lab, don't tell anybody this is a secret, we purposely put a bug in so that you can see this rollback. And so this is showing, that's why it's red, it's showing the Canaries failed and Flagger eventually rolls it back. And we visualize all that in Slack so you can see the Canary starting, it's getting 10% of traffic, it's getting 500 error rates, and then eventually Flagger halts the deployment, and you'll see in just a minute here that red line goes gray, meaning all the traffic stops going to it.
Yeah, really cool. And then sort of one of my pet peeves is people I don't see take advantage, at least in my like the power of distributed tracing. To me, this is a gift, right? Like to be able to sort of get a view of sort of the depth of transactions that actually happen in a way that I think with DevOps, without cloud native, I'm not sure that you could get the kind of sort of, I guess we would call it observability. I would previously call it telemetry. But that's another part here is you're using sort of Istio and Jaeger and then tying that all together and giving people option as part of this lab to actually see the distributed tracing.
Yep, we use tracing to ultimately figure out what went wrong in that Canary deploy, right? We do a Canary deploy, whoops, it fails, it rolls back, everybody freaks out, oh, what happened? Well, good news, we had some good observability tools in place, and so in the final lab, we actually go through, we use Jaeger integrated with Kiali here to dig in and find those errors. So there's traces that flag that they were in error, and you can go in and then look at the details. What was the request payload? What was the response payload? If there was a Java stack trace, that'll show up in the trace, and so it's just correlating together all these different information to ultimately figure out what the error was and resolve fix it quickly.
Very cool.
So
yeah.
Oh
yeah. I mean, so obviously the punchline here of this is, we're setting you up for this, but there's a KubeCon, definitely, in San Diego on November 18th. That's sort of first day when Adult Labs, going to run this again, and I think it gets improved. How many times do you guys run this, Casey? Now,
about 5, I believe.
5 times. Wow. Okay. There you go. So and it's, I'm sure it's improved since Dallas. Sign up, have fun. I mean, I can't tell you how it was really sort of a good level set for me. I do a lot of meta, then I dive into technology for a while, then I jump meta. So this was really a good way for me to sort of just dive right back in, and then I was able to take a lot of the open source, the repo that they exposed to just see like how a lot of things worked under the covers. It was I can't honestly, again, I'm part of the promotion of this. I'm also the an advisor to Liatrio, but I can't tell you how if anything this has interested you, it was incredible, honestly.
Yeah, so if you're coming to KubeCon, sign up for the lab. It's the Monday before all the good stuff starts. So get there early, come join us on Monday. We'll walk through all these different things we talked about today, give you a chance to get hands-on. Would love to meet you and talk cloud native stories. We got one coming up in Bay Area, and then we'll be at the Delivery Conf in Seattle. And then we've also got DevOps Enterprise coming up end of the month. John, you're going to be there, right?
That's right. Yep. So that'd be great.
So I'll be there as well. We've got some giveaways. We'd love to meet you if you want to stop by. This Sonos Move, I mean, that's like a really nice speaker. Am I allowed to enter for that thing? That thing looks pretty sweet. And then I think we've also got a webinar next week we're doing. You and Ross, right?
Yeah,
is that right?
Ross Clanton, the inventor of the DevOps Dojo. So that's
a
great.
little bit. And Ravi from Liatrio will be talking about a little bit of preview of what's coming at DevOps Enterprise. So we'd love to invite you to join us for that too. Cool. Well, I think we're just at the top of the hour. I don't know. Do we have time for a question or two?
Yeah, it's Mitch joining in here. Let's toss out a few questions, and I let our audience know that we're going to go past the hour. One question that we've had is about multi-cloud and enterprises that are leveraging multi-cloud. Can you say a little bit about your experience of using that? Is that something enterprises do for diversity? Has it come because shadow IT teams or IT teams kind of use different clouds and they eventually have to support multiple? What's our decent strategies enterprise are using for that?
I'll take a first crack at this. Yeah, I mean, in general, you have to really be careful about sort of, I sort of despise, I'm glad you used the word multi-cloud, not hybrid cloud, right? I think the term that I prefer is more hybridity, right? Which is, I think sometimes, unfortunately, there's some vendors over the years, and they still continue to do this periodically, is try to sell this sort of, like, we're going to give you the ability to run one workload across multiple clouds. I mean, that's nonsense. It's just nonsense. There's this thing called physics that gets in the way, which then gets into network latency. And like, maybe there's workloads where it may work, but in general, the right strategies are probably to use your sort of plan A, plan Bs, look at sort of the economics of which clouds give you the most value, sort of bifurcate your workload, or not bifurcate, but segregate your workloads in a way that, that you're sort of sensibly working. And I think the more you rely on sort of containers, the more opportunity you have to have hybridity, because then you're not sort of bounded by this sort of the frameworks of the sort of the cloud virtual infrastructure. So just being sort of clever. I will say, I do think, a lot of the newer startups now tend to move towards Google. I mean, you look at, I'm going to get spanked for this one, but there's a lot of sort of, I think that they're sort of secure by design as opposed to Amazon. And so, like, using sort of GCP and AWS strategically across sort of different workloads where it makes sense with the right economics, and containerized for hybridity is probably just, my best answer.
Yeah, I don't have much to add there other than a true active multi-cloud is a hard that is not an easy go. So there needs to be some real strong motivation for that. I think use the right cloud provider for the workload that you're running, and take advantage of the scale that you can get from investing in that provider.
Very nice. Hey, I just wanted to mention too, you had mentioned the webinar that's coming up next week. It's on enterprise transformations, and with Ross Clanton, John, and Ravi. That is next Monday, the 21st at 11 a.m. Eastern. So for our audience listeners there. Question about roles as you migrate from VMs and you kind of go into this cloud native containerized world. What happens to the role of infrastructure provisioner? Does that go away? Does it morph into something else? Are there new skills needed? What's your experience there?
Let me take a stab at that one, John.
Sure.
So it doesn't go away, but it does evolve. I think what happens is the infrastructure. It depends on where they're starting from. If it's a role where they open a ticket, provision a VM, and then hand a VM back, there's a significant change that's going to happen. Ultimately, what needs to happen is the infrastructure role needs to become a role that is offering their capabilities as a service. And so if historically that was offering VMs, that needs to be through some self-service mechanism in this new world, where a developer could say, hey, I need to be able to provision my application that needs to be offered in a self-service way. So that infrastructure engineer is now going to be responsible for whatever this platform is that the product teams are going to be deploying to, and offering easy on-ramps that help enforce whatever the compliance that the organization needs.
Yeah, and I agree with all that. And the only thing I would add is that, whether you're still on VMs or you've sort of gone to the container Kubernetes, you have to make this transition to sort of level up the infrastructure engineers. In other words, they have to sort of move from the old sort of, like, they just sort of checklist they install, and they don't really have sort of, I don't believe that every infrastructure engineer has to be, a full-scale coder, like some people do. But at the end of the day, there's a level upping of skills that you need to have to move to this next generation, whether you're still running VMs or you're moving to cloud native. So the more meta point here is that's an area where you have to sort of focus on leveling up the skill sets of infrastructure engineers, regardless if you make the transition or not.
A similar kind of related question we had a listener ask about in this transformation, what about the role of operations? And it says, role of operations instead of Helm charts. Not sure if that's quite asked right, but I think they're wanting to know what operations role is.
I think it's to me very similar. I think that the right name for whatever this role is now, whether it's infrastructure engineer, or it's still sysadmin, or it's sort of DevOps, blah. It has a whole set of characteristics that I think both Casey and I answered in the last question.
Okay, great. Next one includes a shout out from Jason, who used to work with you, John, at Dell. And his question is, would you consider K8s running on EC2 EKS to be cloud native?
So, let me go real quick, Casey, and I'll give you the longer version answer. I would say no, because I think if you think about what we talked about earlier, I think, sort of my definition of cloud native is sort of all the things, which means that, it's sort of a paradigm shift in the way you sort of think architecturally. It's the way you sort of code. It's the way you behave. It's the way you sort of team autonomy. It's so many things in a broader scope definition to me that sort of just putting things, and I'm not sort of belittling the question, but and hi, by the way, great to hear you again. But Jason, but I do think that sort of that, like, just moving to the technology, and I know you know this, but just for the other people, basically moving to the technology is just not enough in today's world. Casey, did you?
That was exactly what I was going to say, John. Was that
great minds?
Yep.
Great minds. Good job, guys. You were talking about observability before, and of course now tracing is kind of the hot topic around service mesh. Can you say some more about what you need to instrument in your observability, and then what role does tracing play into this?
Casey, go ahead.
So, yeah, let me say this. You want to be able to, you got to measure as much as possible in advance of having an issue, because you don't want to be the guy that says, hey, I got to do a production deploy to add the thing so that I can measure the thing so that I can figure out what failed. So that there's kind of the core grouping of metrics. There's latency, like what's the response time, load, so like requests per second, saturation, so that's CPU memory utilization, so measure those things for as much as possible. And I think that the tooling available nowadays makes this much easier. So being able to, when you're running in a service mesh, like in the case of the labs here, we use Istio, you have the ability to capture all this telemetry data about all the traffic going between services and push that into Prometheus, and then visualize it and alert on it and look at the trends over time. But I think the shorter answer is capture as much as you can so that when you have a problem, you can get to the root cause.
Yeah, it's always easier to solve if you have the data, right?
Yep.
A question was asked about any upcoming events or any resources you might recommend around service mesh.
I think KubeCon is probably going to be the best place to sort of catch up on everything there, in terms of that's where you're going to sort of find the most. I think right now. The most information about what's going on. I think there's an interesting conversation about a service mesh, and Casey and I debated on whether to include this in the webinar or not, and we decided we wanted to focus on like what is the here and now, and here and now has advanced stuff, but I do think there's sort of an evolution going to happen around service mesh, and I think what we see today in terms of Istio, Envoy, there's these what they call super meshes, which are sort of happening. HashiCorp has kind of their interesting implementation of what could be considered a service mesh with sort of Nomad and Console, and then they have a mesh product as well now, and F5 is like playing around with a mesh product. The long story short is, I think right now KubeCon, watch those other vendors, and the ones that sort of in on the sidelines right now, but could actually be major players. And then like Superglue, for example, is a super mesh. But KubeCon has to be, I think, Casey, don't you think, the best place?
Get to San Diego.
Yeah.
Get to KubeCon.
All roads lead to San Diego. Hey, this may be a softball from Jason again. John, he's asking about K8s in serverless applications. What are your thoughts on that?
Yeah, I haven't got my fingernails dirty yet, but the Knative stuff. I'm gonna give a shout out to a good friend of mine, of course I can. Mark Hinkle's trying to build this trigger mesh thing. I think they're the only guys that are actually trying to build sort of hybridity between sort of Lambda and like all the sort of all the serverlesses. But yeah, I mean, I think right now, when I first saw Knative, I was like, oh man, this looks dog ugly. I gotta be honest, right? And then now I've run into a couple of sort of organizations, financial institutions where, I mean, they're successfully moving workloads over there. So it's a thing. I mean, obviously Lambda's been a thing for quite a while, right? No doubt about it, right? Like Amazon Lambda, but that's a very specific implementation. With its sort of own boundaries, and I hate the word lock-in because it has so many wrong connotations, but it Lambda does drive you down a very specific path of how you sort of behave with function as code. But Knative, all right, so I wasn't going to go along on this, and now I am. I mean, one of the things I thought was always an issue with Lambda, which was the manageability of it, right? And one of the things I sort of like, even though I didn't grok the first implementation of Knative. Knative basically is again, haven't got my fingernails dirty, but you deploy Kubernetes clusters and containers, and then the functions run inside the containers, but it is sort of constructed in a way so it actually is a true function as a code implementation or serverless implementation. The advantage of that model is you have a service mesh, right? And that you're going to need that, right? So, and I think, where Lambda goes, where sort of the collaboration of all these sort of serverless implementations out there, the IBMs, all these different implementations, at someday there's going to have to be sort of a common way to do sort of manageability, all the mesh things that happen. And right now, correct me if I'm wrong, anybody, Casey, I think Knative is the only one that actually has this in-your-face opportunity to have sort of a service mesh and a manageability option.
Yeah, it's definitely the on the forefront. And the only thing I'd add here is I don't like the serverless or Kubernetes or containers conversation because I don't think it has to be one or the other. I think really it's a question of how much bang for the buck can you get quickly? So an enterprise that's takes 30 days to get a VM and they've got these manual processes. If they could take an existing app and get some huge wins on their agility and their safety by containerizing an existing workload, that's a huge benefit for them. Whereas I think if we were building something greenfield, yeah, we're gonna have a real serious look at serverless because I think the app architecture, it lends itself to better architected systems, but it's a harder lift to go from an existing 40 million line monolith to a serverless app.
Yeah, and at the risk of sort of going way over, like to get philosophical, I have a good friend of mine who's writing a book about sort of event, the sort of this new breed of where sort of event managed, event sort of the thing that you get sort of with Lambda or the event, the serverless gateways and all that stuff, right? Like, but what's going to happen, right, is all this stuff has got to flesh out. This is why I think the service mesh of today is going to change, in that I think there's a new horizon of sort of architectural at scale beyond even infrastructure of sort of, and I'm getting very meta right now, but I do see this sort of opportunity for a lot of things in just general sort of software commerce, if that's a phrase, will change based on sort of this new paradigm of sort of that has been canopened by serverless, really just event driven work.
Yep, I would agree.
Yeah, good stuff.
Oh, excellent. I think we've emptied the tap on our questions here. So guys, and by the way, John, I like your idea of the Batman gloves. Maybe we'll have to merchandise that some.
There you go. It's sort of cloud native.
Well, thanks, John. Thanks, Casey, for your excellent answers, and of course your presentation today. And I really appreciate the way that you both collaborated on that. I'd like to thank our listeners for hanging in there with us. We had a lot of folks stay on. And of course, your questions were fantastic. Just remember that our webinar recording is available. We'll send you an email with the link to the slides and recording. You can also get those on digitalanarchist.com, where we also have other webinars coming up. So check that out. John Willis, thank you so much for being a part of this, an industry keynote speaker, DevOps, author, expert, etc. And Casey Lee, Director of Engineering at Liatrio. And of course, thank Liatrio for sponsoring today's webinar. Thank you, everyone. Appreciate your time from the audience, spending your valuable time with us. It's been my pleasure. Everyone have a great day and be careful out there.
Yeah, thank you.